instructions at the same time, including executing it as I have 4 ALUs in the system. It's possible that I don't have multiple IRs. I don't have multiple write-back units. But it'll make the processor useless, really, if I'm trying to do superscalar processing. So one design of superscalar, we are seeing it right now. Doesn't mean that's the only design there is, okay? And we'll finish the superscalar today by looking at what happens if you have things which are dependent on each other. How does that work? Because dependency always causes problems. So the question on dependency came up for 2 people. So one thing, dependency is not a pipeline issue. It's not a pipeline concept. Dependency exists regardless of the kind of system there is. As long as the source and destination are dependent, there's a dependency. Number one, doesn't matter how far the dependency is. To your question, that doesn't matter. You could be first line and 500 lines. Dependency is between if the destination of one instruction is the source of another, dependency is there. Would the dependency cause an issue? That only happens during the execution. Okay? So dependency has nothing to do with pipeline. Dependency causes data hazard during the pipeline if the dependency is close enough. So that's the distinction I want to make. So you can have dependency in a single cycle execution. We had that when we started the dependency conversation earlier. Third or fourth lecture, that 2 instructions can be dependent on each other as long as they're sharing source and destination. So pipeline is just making it worse, but dependency exists regardless. And there is no limit on how far a dependency can be. One. Second question is dependencies in a loop. The dependency is only dependency once. Just because you're going through the loop doesn't mean you're going to write the dependency out 500 times. Okay? Hint, hint for the exam. That if you have a loop and there is a dependency and ask you dependency, don't list 500 times the same dependency. You can say for every loop, instruction 3 is dependent on instruction 2 on this. Okay? Or just leave it that way, instruction 3 is dependent on instruction 2, and I'll understand it. Because dependency is dependency. Again, nothing to do with execution. It's dependency between 2 instructions. When will I know there's a loop? When I execute. Maybe there is no loop. Maybe I'm only executing once. Then it cannot be 500 times. That's number one. Number 2, there's one problem set in pipeline, hint, again, that has one line which is wrong. I want all of you to get there together. One person found it and sent me an email. Already, I have not replied to that person yet. But whoever you are not wrong. Okay? But I want all of you to do the solutions as if you don't have the solution. So you understand the pipeline truly. Just don't look at my solution and oh, this is how he did it. That's the solution. No, it's not. Okay? So intentionally, as I did in the second set of problem sets, there was one wrong error. Same thing is happening with the pipeline. There's one problem with the one line of error. Okay? So that's those are the 2 questions that came up, 3 questions that came up. So question first and then question.
I was going to say that you said that on the exam do not repeat dependencies because of a
Dependencies are dependencies.
Say one time.
They are between instructions. Just because you have a loop, you don't know it's a loop until you execute. Hazards are caused during execution. Dependencies are within the code. 2 different things.
And which was the problem set that you were referring to again?
I did not say anything. I just said problem set. Yeah.
I have a scenario that we're going over real quick. Basically, I just want to know, do you mind writing it out?
I do mind. Ask him.
Okay, so imagine in Python you have a load instruction that has freshly coded exec.
The load instruction after that.
And right after you have an R type that has a dependency on it.
Good.
Okay, and it's freshly code stall exec.
Stop executing.
Yeah.
Number 1. You have a dependency between 2 instructions. Correct? So you have your good. And you're executing it. First one, there is no dependency. It will continue. Fetch the code. I cannot get exec because I need R1. There's a data hazard. Data hazard will not be available until the write back. So I install. Then I exec. and then what is it, R-type, go up, and right back.
Okay, so, yeah, so my question is, how come it exec's right there? I thought I would have to wait for the instructions to finish. I think that's the part I missed.
Instruction to finish.
Yeah.
I never have to, in pipeline, I don't wait for the instruction to finish, I wait for the data to be available.
I thought it was ready after write back from Lowe's, because that's when
Good,
Lowe's is.
how long write back takes?
2 days.
Sorry? It's in your notes.
1 second.
1 nanosecond. So, when I write this is not happening in parallel,
Oh,
okay? The whole point of this conversation last time when we did timing was, first line will finish whenever it finishes. This exec needs R1. I have in the MDR R1 at the end of mem. It'll be written to R1 during the write back state. The write back and exec are not happening at the same time. It looks like it's in the same cycle, but the timing is a little bit off. And how do what allows me to do that? Because I am expanding each stage to be the worst case. Fetch time. So if that's the worst case it's going to take, anything that fits in within that stage can all move slightly over. And that's how we do it. You have a question over here?
No, not really.
Okay, so those were the questions that came up. Let's wrap up on our superscaler and then see our last topic. So same 4 instructions that we have, 2 L types, R type and S type. A equals to B plus C. A equals to B plus C that we've been doing, and we've been trying to improve them. From your 5, 5, 18 stages, we went to 9 stages in pipeline, and then we're going to try to do that better in the superscaler. You know, the problem with pipeline or any execution is when you have 2 instructions that are dependent, you will always have a delay. Why? Because that's how you wrote the code. It's not a choice. You are waiting for the right value to be in the register before you can then calculate things. So I'm going to fetch all 4 at the same time because my superscalar design allows me to do that. I'm going to decode all of them at the same time because it allows me to do that. Okay? And first 2 instructions in our A equals to B plus C do not have any dependency. So they can continue. They can continue, but just be mindful that you know that this exec and this mem, they're sharing your MAR, MDR, and the control. And the mem is sharing the memory bus. So as soon as the value is put on, the MAR and control for the first one is pushed out. So your first instruction is truly fetch, decode, exec. Fetch, decode, slightly off the exec in there. Because I do not want to override second instruction, getting it override the first one's MAR. As soon as the MAR is dumped in the memory bus and the control, then this one will go in, and they will both come back in that order. Okay, they will both come back in the order. So when MDR value comes in, that will be written here, and that will be written here. So those 2 have sped up completely. Remember, 1 cycle less now. Because first time when we did it, fetch, decode, exec, mem, write back, fetch, decode, exec, mem, write back for a normal pipeline, for a scalar pipeline. Superscalar, I can finish both of them in 5 stages. When I try to execute the 3rd instruction, 3rd instruction has a dependency on 1st and 2nd. Okay, 1st and 2nd, they have a dependency on. So I cannot yet start executing that instruction yet. So regardless of scalar or superscalar pipeline, you still have to stall the 3rd instruction. Why? Because if I start calculating exec right away, even though I have an ALU available, I cannot use that ALU because the input that I need will be available in 5th cycle for me. So I can do exec here. Going back to the earlier question that was asked. There's write back, and exec. Are they happening at the same time? Not really. They are slightly off because I'm still within the fetch margin, the worst case cycle length margin. so I can expand things. So it's literally right back slightly off, exec after that. So that way, I have these, fetch decode exec, then no op, and then right back, and then you have fetch decode. The third instruction is depending on, the fourth instruction is depending on the third instruction. So I cannot yet start using the destination of third instruction until I have it available. I will have that available at the end of exec. Okay, at the end of exec. Now, most of you will try to do this. And it's perfectly legal to do that. Okay, because of the same concept that we're doing. What did I just do here? I did a data forwarding. Okay, I did a data forwarding from third to fourth. To be safe that the Z value is available at the end of exec, usually the scalar pipeline will not start the exec until here. Okay? Until here, because the Z is available. As you can see, I already added delay. I can add the second exec also. That is perfectly normal. But just so you are aware of it, that delay is not a full stall. It is truly happening right under there, because the exec value is available at the end of whenever the third instruction is complete. So I can start my exec here, and that's a perfectly valid answer. Okay? So if you understand what do I mean by that, by stalling it, I'm trying to guarantee that the Z value is there. That's all. Okay? Yes?
You said scalar, so that includes.
Superscalar.
So that doesn't include normal scalar?
This is superscalar, that's all, that's why I could do this. I could not do this in scalar, correct?
Right, okay,
So in a normal scalar, I would have stalled anyway.
right, okay.
Because I cannot forward in the same cycle as I'm calculating it.
Yeah, okay, and then, so, like, both of them would be E, like, you could write both of them as E as well?
You can have the exec, both of them are in the exec stage.
No, I meant for the last one, like, you could write like FFBSSEE, if you understand.
There is no
what I
EE.
meant.
There's only one exec,
Okay,
correct? Either exec is happening here or happening here.
but you're saying that it's okay to have it.
If I wrote it here, I would not put it there.
Okay, so it's just based on the architecture?
Correct.
Design, okay.
So that's why I'm stalling it, because keeping the same thing in mind. In scalar pipeline, we were able to forward from one instruction to another in the next stage, because that's how at the end of the Z, for exec, the value is available. Then I can forward it, and the same concept we apply here. So fetch decode exec, then you have mem, and you have write back. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 cycles in superscalar compared to 9 in scalar. So I didn't get that much improvement. Okay, I didn't get that much improvement compared to 18 in a single cycle. That had major improvement. Doesn't mean superscalar is bad. Just that because the example that we're looking at from single cycle to pipeline to vector, we have seen improvement. Question and question.
Isn't that a store?
Would it be 7?
Thank you.
That's what I was gonna ask, but also, we're only able to do the write back exec because there's a slight delay, correct?
It's a slight delay.
Okay.
You just have to know. Write back is happening in individual core now.
Okay.
So I'm not sharing the write back entity. So that's the good thing about the superscalar, that how each of my core is designed, does it allow me to do that? My design is allowing me to do that. It's possible that there is only one write back. And that core design will not allow that.
And there's a slight delay between the two write backs and stuff.
To write back, just because I'm grabbing the MDR, putting into R1, and the next MDR is coming in and I'm putting them.
Okay.
Yes.
So, I know that each core has its own ALU.
That's a minimum.
Okay, but are all of those ALUs connected to each of the Z registers of each other? Because otherwise, how else would they know?
Each of the ALU have their own output register.
But I'm saying, are
But
all
the
of them connected?
Within the processor, you have to have a connection How do I know there is a connection? What did I tell you guys on Monday that addressed that there is a connection? What else they share? All the four processes, four ALUs.
Oh, GPR.
General purpose register. So for me to be able to write to same set of register, they all need to be talking to each other. I cannot have an input coming from a different register going to another input so your ALU bus just got more complicated between the cores. It's not just on that. You still have one processor, keep in mind.
So,
Single processor, multiple cores, all of them talking to each other.
so does each one have its own Z register, like in the G?
What is the Z register?
Well,
It's the ALU output. So
Yeah.
every time you do a calculation of ALU, there's always an output.
Mhm.
And that output is connected to the ALU bus. It can go to any GPR as you need it.
Okay.
Good? So if you have two R-type instructions back to back, happening on two different cores, then one Z can write to one, another Z can write to another. That's what speeds up the last time that we saw that calculation, 4 of them, they were all ALU operation, no dependency. They all finished in 5 cycles. And that's the speed up. So the multi-core or superscalar are really good when there is no dependency between the instructions. If there is dependency, it sucks. Sometimes it performs worse than the regular pipeline. So now you're just stalling until the data is available. Okay? So you will be told what hardware is available in your superscalar. Okay? Whether you have multiple IRs, whether you have multiple cores, but how many cores you have. Maybe you only have 2 cores. Then you can only fetch 2 instructions at the same time. So just be mindful of that. One design change that Intel versus AMD, they do, that in our design that we've been looking at, simple MIPS architecture, each core has its own IR. I can fetch an instruction. Reminder, fetch is different for superscalar than for scalar or for single cycle. The change we did yesterday. But some multi-core or superscalar processors have one IR, but the IR is designed differently. IR is not designed as a register, but as a buffer. Multiple elements can be in that. It's a buffer in terms of software terminology, but it's a queue that is pulling instruction as they're coming into IR. So I can have 4 or 5 or 6 instruction in the IR buffer instead of having IR on each core. So it's just a design issue. It still needs to go to IR, but I need to keep track of which location of IR is the which instruction. So that adds more complexity. In case you read about it, or you're watching YouTube, and then somebody mentioned IR buffer, that's the design difference. It's just instead of having one register, you have multiple buffers that are still holding the number of instruction equal to the number of cores. You can't have more instructions than the cores you have available. So if you have programs that are very data intensive, calculation intensive, okay? You all know, most of you know, of programs that are calculation intensive. Video games. They are very calculation intensive because they need to calculate the graphic output for you, pixels for you. Game design requires a lot of data churning. And they're not dependent on each other. One pixel is not dependent on second pixel when I'm showing it. For those, multi-cores are great because I can process more data at the same time. Second application is multi-threading. Okay? Not multi-programming, multi-threading, which is one program having multiple sub-programs within the same memory space. You'll learn this in your computer operating system class. But multi-threading uses multi-core a lot because all the sub-programs within the program are not dependent on each other. So they can all execute at the same time, making things faster. Think about simple question like adding an array. You have an array of 100. You want to add each location. You can pass half to one thread, half to other thread, and then at the end, they're both working on the same array because they can share memory. Result is literally half the time, okay, because of the multi-core. So multi-core is not useful everywhere, but know the limitation of multi-core. Multi-core is great for data processing but not great if you have dependent instructions. Multi-core is still one processor. One processor equals one program. So it's not that I'm running multiple programs at the same time. It's ILP at the max level. Yes?
So multi-core, like, could it speed up certain algorithms?
Oh yeah, definitely. I can run binary search,
Merge sort?
merge sort, half of it because you're literally splitting it. So you can do one half on one core, another half. As long as there is no dependency, you're good. If you have dependency, garbage. Dependent codes are bad for superscalar, or for any computing literally, because you have to wait. Might as well do single cycle, okay? So one processor, doesn't matter what kind of processor it is. From day one until last week, we were looking at a single core. To date, we added multi-core. But what you need to remember is that if you have one processor, you can only have one process executing at any given time. That process can use multiple processor, but other than that, nothing else. So we go back to our original concept of multi-programming. Multi-programming is the ability of an operating system to manage multiple programs at the same time. Okay? Ability of an OS to have multiple programs in the main memory. They're not all executing. I don't know what the architecture is. This is a OS level concept, not a hardware level concept. So for me to be able to run multiple programs, I need a system that can handle multiple programs first. Okay? So this is an OS concept. How many programs are currently in the main memory? You all have your computers where you're running multiple programs? You think, but no, you're only running one program. You have multiple programs in the main memory that the system is switching between them. Okay? We have had one CPU. That means my OS can take one of the programs that is in the main memory, bring it to the CPU. We have learned how to do that. We assign the value of the program counter for that program onto the program counter register and let the CPU do its job. CPU will start fetching the instruction and executing it until it dies at the end. Or the OS can take currently running program, take it out, and bring another program onto the processor. It can switch between programs that you guys see on your computers daily. When you switch from Chrome to Microsoft Word, that switch, you are requesting the OS to say, stop running Chrome, run Microsoft Word for me. Okay, while Word is running, Chrome is just sitting there, ready to run in the background. Until you switch back the screen, then it will run again. So the OS's job is to keep switching between processes by changing the context of the processor. Very high level process management for this class, but what you need to know is for you to be able to do this, switch between programs, you have to have an OS that is capable of multi-programming. If the OS is not multi-programming, only one program can be in the main memory at any given time. One processor, one program can run. We have already learned during our messy conversation and in our multi-core conversation that I can have a system with multiple processors. Okay, if I have multiple processor, how can I leverage the system to maybe able to run multiple things at the same time? This, having multiple processor, doesn't mean anything. You can go and buy 4 processors. If your system doesn't know how to look at them or how to manage them, waste of money. It will still just run on one processor only. So for you to be able to utilize underlying architecture, you need to have a multi-processing system. Again, awareness of the processor is required. If the system is not aware or cannot handle 4 processors, 3 processors are garbage. It can only use 1. By having 4 processors, this is not core. This is unique, distinct processing units. Okay? Not multiple cores within one processor. I want to make sure you know the distinction between both of them. That this was the CPU we're looking at. 1 core or multiple cores, pipeline, superscalar, whatnot. Now I have 4 of them. Advantage of multiprocessing is I can run multiple programs at the same time. Okay, 4 processes can be executing in parallel. Multiprocessing allows me to do parallel programming. That is only possible if my operating system is a multi-programming system. So I can have 4 processors, but if my OS is not capable of handling multiple programs, I cannot run multiple programs. Because how do you run a program? You bring it to main memory, then you bring it to the processor. My OS can only handle 1. I cannot bring 4 programs to main memory. I cannot run 4 programs. So truly utilize multiple processors, you need to have both multi-programming and multiprocessing system. Okay? That allows you to do complete parallel programming. Questions on definition?
On the single CPU, you can set up a multi-programming operating system if you have multiple cores.
So for this conversation, get rid of core from your head for 1 second. Multi-programming is operating system.
Yeah.
It has nothing to do with the architecture.
Yeah.
So you can have a multi-programming system with 1 processor or 4. Correct. Most modern operating systems are multi-programming. You all know it because you do it every day, multi-programming. Okay, even though you think you're running, as we said on the day 1, you're not running 50 programs. Most of you only have 1 processor on your computer. Some of you have 2, I think, if I remember. That person dropped the class already. So they went too fast. So if you have more than 1 processor, you can run truly 2 programs. Most of your programs are not utilizing those 4 processors. You don't need it, okay? Parallel computing is a great field. 344, I believe, the class, is dedicated to distributed and parallel computing. The entire class is about how do I create programs that can be created or split into 4 programs, okay? So if that is not the case, that I don't think 344 is required, but if you want to learn about that, that can be the class you can take. Is that a question?
I don't think they offer it anymore.
I think they offer September 15, same as 344.
Or, like the distributed systems or whatever?
Yeah.
I don't think it's been like running there for.
Oh, because I don't teach it anymore. But you don't want to repeat a class. 1 was enough, correct? Yes. So, but in case they offer it, it's an elective. So we want to be able to utilize multiprocessing and multiprogramming. But for this to happen, they both need to be true. What do I mean by that? You've seen example of this in, I believe it's in final. Last year's final, there's a problem, page 3. You have program 1, program 2, program 3, program 4. Just understand this and I'll let you copy it, so just be mindful of that. You're given 4 programs with 3 lines of code on each, okay? 1 is 3 line, 1 is 4 line, 1 is 7 line, 1 is 8 line. Then you ask 4 questions after that. So 4 programs, question 1. What is the total execution time, okay, total execution time for that program, or what is the total number of cycles for that program if you have a multi-programming system but no multiprocessing? Okay, I want to make sure that you understand the question. You have 4 programs that you want to execute. Scenario 1, you have a multi-programming system, but you only have 1 CPU. And it's asking, give me the total number of cycles that it will cost me to execute them. Okay, it even said single cycle execution to make your life easy. So I can only run how many programs at any time? Why not 4? 1 processor, 1 process, 1 program at a time. So if I have 4 programs, how many total cycles it will take me to run those programs? How would you figure that out?
You have to add the cycles for each program.
Add the cycles for each? Literally add them up because they're going to run 1 by 1 by 1 by 1, one after another. Program 1, program 2, 3, 4. I don't know what order, but they will run in that order. And just by adding them, add all the cycles, that's my answer. Simple. Because I can only run one. Second question was, you have a uni-programming system with multi-processing system. Uni-programming with 4 CPUs. How much time will it take me? How many cycles?
It depends on each, because,
No, doesn't depend. 4 cycles?
4 cycles, but each.
How many, what kind of operating system you have? What does that mean to you? Say it again?
It's combined.
What do you mean combined? There's a multi-programming system, there's a uni-programming system. What's a combined system? It's a new one. What's a uni-programming system?
You just said it can only handle one, program at a time. The operating system can only handle one program
Where?
on the main memory.
In the main memory.
So.
So
it
for
would
this?
be, you know,
You have 4 processors and a uni-programming system. How many total cycles?
It would be the same as the first
The
one.
same as the first one. Because how many programs can I bring into the main memory at any given time? Only one. I'm going to bring one, run it on one of the processor, who cares which one? Bring the second one, bring the third one, bring the fourth one. They are not running in parallel. They're going to run sequentially. So same as the first answer. Yes,
And the answer would still be the same if it was
we're getting there, one by one. I'm just going through all the scenario there is. Third is a multi-programming system with 4 CPUs. What is the total number of cycles for all the programs?
It would be the program with the most lines.
Listen to my question. To this question, everybody got it wrong last year. What is the total number of cycles to execute all programs?
Oh, the same as the.
Same as the first 2. The total number of cycles doesn't change. So the answer that you were giving me, what were you giving me?
I was giving you
The best case
Best case time.
scenario. Okay? Because I have a multi-programming system, what does that mean? I can have all 4 programs in the main memory at the same time. Great. Now I have 4 processors also. I can schedule them all at the same time, so they start running at the same time. So what he's saying is that the total time, the time that he was giving me, is whoever takes the longest. Okay? Whoever takes the longest. So if program 1 had 4 instruction, 3 instruction, 11, and 5, we know that program 3 will take most number of cycles, and by the time program 3 executes, P1, P2, and P4 will be done. Okay? Hopefully. So that's the best case scenario he was given. I didn't ask for best case scenario, I asked for total number of cycles. There's a difference between, best case and total. Is that clear to everyone? Those are the 3 different architecture that we have. Fourth one would be that, what if all of them are pipelined scalar processors? So you have multi-programming, multi-processing. Not only that, now you have each of those processors are scalar pipelines. How many total cycles?
Sorry, can you repeat the question?
You have 4. You have a multi-programming operating system. Same 4 programs. You have 4 processors. Each of them are scalar pipeline. I have 4 programs that are going to execute. Provide total number of cycles for all 4 programs.
Doesn't that depend on
Depends on,
the instructions and their dependencies?
what do you mean by that?
Because,
Can you not tell me how many cycles right away? Why not?
because, there, since can't we have like stalls and no-op stuff and,
Because you don't know how much time it's going to take me in the pipeline. How many cycles it's going to take depends on when I start executing in the pipeline. A single cycle is easy. every instruction takes one cycle. No longer that definition applies. Okay? So you will have to actually execute all 4 instructions on pipeline structure. See if there was stall, whatever it was, and calculate the total cycles based on sum of each. Yes?
So to answer that question, we'd have to like, draw it out with each. And,
I can be sadist. I can ask you that kind of question.
and if that was to be given like, for each program, we'd be given each instruction, and then we should do
For
that.
each of them, you will do the pipeline, yes.
Gotcha.
That's a good question, yes? Yeah.
It's the
Do
whole
like one instruction for each program now.
What's the point of that?
Exactly.
You already have an example in the exam from last year
That
that has it, something similar.
is a good question if it's like 80 points probably.
I can do that. You want it? 100 points, only that question.
That's-
Can we do 100?
You're gonna regret it. Question.
And just to reconfirm, wait, UP, that's, you said that's uni processing?
Uni processing,
So it-
uni programming.
And that's that it can only do one program at a time?
The uni programming system can only bring one program in the main memory at any given time. If you cannot bring more than one program, you cannot execute more than one program. Okay, so those are the architecture and the system concern. They are improvement on our scalar, superscalar, or single cycle execution. For me to be able to truly harness the power of my systems now, simple for loop, okay? Simple for loop, and you have I going from 0 to 9, and then a sub I equals to b sub I plus c sub I. Nothing fancy, you have seen the code, a equals to b plus c, same concept, but slightly elevated. That you have a program that is going through the loop, is going to go through 10 array locations. Array locations are nothing but memory addresses. B sub I is an address, C sub I is an address. I'm going to go to those 2 addresses, bring data from there, add it up, and store it into A sub I. So this one line of code in the middle results in 4 lines of code in the RTL for a for loop. Okay, for a for loop, and I'm just doing that 10 times. In the back of your head, as soon as you see a for loop, a while loop, you should be thinking, crap, that's a branch. Okay, that's a branch, that means that's going to cause a control hazard every time. Is everybody clear about that concept? That whenever you see a loop, comparison, to change the direction, should I go to the next index, or should I get out of the for loop? That's a branch in your head. Any questions on that? So here, I have 11 branches. Okay, first 10, and then 1 to get out. So if you have 11 branches in this code, when you execute it, every time you execute those 4 lines of the code, along with that, I have a control hazard every time. Now we know the solutions to control hazard. We can stall until the value of the next PC is available. We can fetch the wrong instruction and flush it out, or we can do branch prediction. Either of them will work, and branch prediction will work really well here. If I set the branch prediction to taken, first 10 times will be good. 11 times it will fail, and I will get out, and I will just fetch one on wrong instruction. What I'm trying to do is, I'm trying to get rid of all control hazard from this code. How do I do that? So do you understand the control hazard where it's coming from?
From the branch instruction,
Where is the branch?
the for loop.
For loop. I want to get rid of every control hazard when I'm executing this instruction. How would I do that?
Can't we do what we did before, where we can assume that the branch will be taken?
I want to get rid of all control hazard. What causes control hazard?
When
There's a branch.
uh,
Simple. Okay? So when I say I want to get rid of all the control hazard, I'm saying I want to get rid of all the branches. How do I do that?
instead of making it a branch, we can say we have like 10 instructions here. So like
Tell me, I don't know how to do that.
so like a sub 0 is equal to b sub 0 plus yeah. Oh yeah, yeah.
You got rid of all the hazards in one shot. Okay? Simple solution to get rid of all the hazards. How many of you have done programming like that? It's very easy, just copy paste, yeah? Change the index. 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You know control hazards are bad during execution. So why would you have a code with control hazard knowing that in advance? Your 111, 211, 212, 338 instructor will say, who taught you that? Okay? But you have more knowledge now. This code causes hazards during execution. That code does not have any control hazard. Zero control hazard, faster execution. Okay, so you are going to optimize your code by doing that. Any questions on that? What he just did? Let's change it up a little bit. Okay? My for loop is going I less than 99999. 99,000? Yeah. 99,999. I want to get rid of all the control hazards. You can do the same, yes? If you have no life, do that. Or you can write a program that does it for you, correct? Yes? You can write a program that takes the loop and expands it for you. That's what we're doing, yes? When you type a sub I equals to b sub I plus c sub I, then 0, 1, 2, you're going to type it. Can't you write a code that will do that for you? Yes?
So isn't that what the compiler does?
What does that mean? Compiler does.
Like,
How does it do that?
takes your code and it's gonna write out all of it, like the 99,000 times.
So it's going to write that many lines in the code out. Is your code becoming very big? Yes? Everybody can see that? Right now I have 3 lines of code, or 2 lines of code, for loop and a sub I. If I write that out, that will be bad. So my compiler, good answer, will not change the code. What does compiler do?
Or it's gonna take your code,
No, in English, plain, don't worry about what it does. What's the output of a compiler?
machine code.
Executable. Okay? So the job of the compiler is to take your text code, give you the compiled executable. So your compiled executable will have those line by line. Compiler optimization design. Compilers do that to avoid hazards during the execution. This is something the system does it right now, called loop unrolling. Actual technique used by the system. Because it has learned the for loops will cause hazard, let's expand. You don't want to expand the code too much. Your text file is not changing, keep in mind. Your program is still the for loop, but when it's compiled, the loop unrolling happens. So there is a limit on how much loop unrolling is good. If it's 10 million, your executable will be so big that you can't fit it. Okay, because executable machine language will occupy more than what you need to. So sometimes it's good to leave it as is. Yes, it's going to cause hazard, but I don't have space for the executable. Okay, that's one thing that system does. You all have written programs where you declare variables. You never use them. Okay? Int my name, int my last name, int my age. Have you done that? You never declared a variable that you never used.
I always.
You always what? If I go through all the classes you have taken, look at all the code you have done, there's never a single variable you have declared that you haven't used. Can you guarantee me that? But your IDE guarantees that for you. You all have become dumber because of the IDEs. How? Because IDE tells you this variable is not referenced, not used. So it's not that you haven't written, you haven't saved at the end, because your IDE told you, you haven't referenced this variable, get rid of it. Most older IDEs were not that smart. Okay? So you could declare a variable int ABC, never use it, nothing wrong. The problem with that is, it's gonna occupy memory when you declare variables in your code and your data memory. So your compilers optimize the code by getting rid of any variable that is not referenced in your code during the compilation. It will optimize that for you. So if you have taken 300, I think, is it programming language 300 or 316? 316. I hope they touch on that, compiler optimization. But if not, high-level optimization, the reason it's needed is because of the execution. Our concern is, how do I take this program and execute that on a system that has 10 CPUs? Okay, 10 CPUs. I want to rewrite that program, original one, sorry. And I want a fancy system with 10 processors. Doesn't matter if it's unit programming right now, but I want to be able to run this program on 10 processors. And run them so fast that the amount of time it'll take me will be 1/10 of the total time. Okay? Right now, this is one program. Add array.exe. The way it's laid out, I can't do that. Because one program, one processor. If I have a multi-core system, great. I can run 4 lines at the same time. That's what I want. If you notice this code and the optimized code that is there on the side, each of these subscripts within that array is distinct from the other one. A sub 0 calculation has no dependency on a sub 1. For that one line of code, there is dependency, we know that. A equals to B plus C, 4 lines of code, those have dependency. Third line has a dependency on 1 and 2. Fourth has a dependency on the third one. But each array subscript does not have that dependency. So if somehow I can take that piece of code and split that code to be able to run on 10 different processors, then I can execute them all at the same time. For me to be able to do that, I need a system where I can actually create a program from another program as I'm executing. Is your hand up or? Be able to create a program from another program. For that purpose, only entity, so this is the code, keep it in mind, only entity in the system that can create processes or programs is the operating system. No one else can create programs in the system, only the OS can do that. Users can request to run a program, that's all. Then you click on the program, you're asking the OS, please run it for me. OS will load it to memory, OS will allocate the piece processor to it, and then it will run. So what I want to do is I want to rewrite the code that we have in the system so I can request during the execution that, hey, for each of those array subscripts, I want you to create a new program and run that program separately for me. Okay, so the goal is take one add array.exe, and as it's running, as it's executing, modify the code to split that into multiple add array.exe. Number one, for me to be able to do that, request the OS to create multiple programs. What kind of OS do I need?
The multi-programming,
Why is that?
because if it's a unit programming, it won't be able to run multiple programs at the same time.
Say that again,
So if it's
correctly.
Okay.
So don't get to run yet. If it's not a multi-programming system, why can I not do this?
It can only load one program as a main memory.
And what am I trying to do?
Load multiple.
I'm trying to ask the OS, put multiple programs in the main memory. That is only possible with a multi-programming system. So this is not possible, what I'm trying to do, with a uniprogramming system. Furthermore, what else I want to do? I want to run all of them on the 10 brand new processors that I just bought. So it better be a multi-processing system also. So your system must be capable of multi-programming and multi-processing for you to be able to take one program and split that into multiple programs for yourself. Okay? And that's what we're trying to do, and how do we do that? When you are trying to run any program as a user, the OS goes through multiple steps before it runs that program. Step one, finds the program in your hard drive, that executable. Second step, brings that executable into main memory. Okay, allocates the memory to that process, allocates identifier to that process. It says, you are process number 10, you are process number 11, all that. Anything that process needs is allocated to that process by the OS. The functionality or the function of the OS that you use to load a program is called fork. Create process or fork. Depending on your OS, if you have Unix-based OS, that will call fork in C++ or C. Windows uses create process. Windows is very straightforward. Oh, what is the process does? It creates a process. Fork is, as the name suggests, it splits a process into multiple substreams. Okay, multiple substreams, you're literally forking. You have seen, if you use Git, you fork a repository, you're creating a copy of that and downloading that. Same thing. That's where that fork concept comes from in the GitHub. That what does fork means? Take one full code, take a copy of it, and then you can change it. You can do other things with it. But we are going to use the actual fork system call that is part of the OS, which OS uses to create a process to actually split this into multiple processes. Yes?
Oh, you see the OS, so like, what if you try this on an online compiler?
It will fail.
It'll fail.
Because most online compiler will not allow you to fork it. Because you are, what are you trying to do? What is an online compiler?
It's compiles code
Compiles and runs. Runs. So where is it running?
on the website.
On their machine. So if that particular IDE, online IDE, allows you to create this, they're stupid if they allow you to do it, because somebody can write a for loop and just keep forking and just keep creating processes forever. That'll crash their system, okay? Or you can go to Linux. Anybody has an account on Linux?
Yes.
Go there and crash the system after tonight, once you learn how to do this. I've done that every time. And usually I tell them that I'm about to teach this particular topic, so they expect it to crash. So tonight it crashes, it's okay. So some IDEs will allow it, but then will kill it after a while. I've seen online IDE, I think that has a C++ compiler, that does allow fork, but not in a for loop. It'll tell you, do not do this, or something like that.
And so you mentioned there's only C and C++ then?
C and C++. This is truly our OS level call. The code is part of the operating system. I'm going to use that to do this. You have all used the OS code a lot of times. You've done fopen, okay? You have done cout. You have done printf. What are those things? Those are system calls you're doing. Those are interrupts you're doing to ask the OS to do something for you. What does printf does? It outputs to the screen, or to a file, or whatever you want to do to output to. So those system calls that you're doing, I'm going to use the system call to create processes. Question?
Is that part of the standard library or you?
This is part of OS.
Oh, and you part of it.
It's literally part of OS. When you install the operating system, Windows, that's the process in there. When you install Linux, that is in there. Yes?
So why can't a language like Java run this kind of process?
But Java has better things than create process. Java is a process itself, correct? When you do Java and you run that, that's a process running. You're asking the process to run another process. It can do that. We use multi-threading in Java, but Java can also do create process. There's something called process builder class, you can look it up in Java documentation, process builder, that you can use to create another process.
And is create process just another name for fork, or are they two different processes?
Two different operating systems. This is Win32, and this is Unix. Does the same thing. Does it differently, but does the same thing. The point being is I'm trying to take one process and split that into multiple processes. We know what our process looks like. It's a for loop. Goal is for every index, okay, just for that index of a sub I want to take that and I want to spawn a new process just to handle that piece of it. Okay, that piece of it. So what does fork do? Fork creates a brand new process every time you call it. How do you call it? You double click on an icon, you type add array.exe. As soon as you hit the enter key, the OS will call the fork method, allocate memory to it, the process, and bring it to main memory to run it. So we are going to utilize that for our purposes also. How does it happen? So we know that for loop is there. Within our code, I'm going to call the fork method. For 1 second, stop right here. Understand this, and you understand this, you learn multi-programming very easily. You're going to invoke the fork method, which is just line of code in there. That is a system call that you're doing. Okay, just like fopen, cout, printf, cin. Anytime you request things from the OS, you make a system call. That fork system call will do something for you. If you as a user had typed the name of the program or double clicked on the program, the OS will create the process for you. How does it know which process to create? Because you typed that. You said hello.exe. You gave the name to it. When your code calls the fork method, it's slightly different. There is no parameter passed to this particular method. Fork is just that, fork without any parameter. OS will automatically take this actual exe, actual process, and make a copy of that in the main memory. Okay, make an exact copy of that in the main memory. If I keep calling fork multiple times, I will have 10 copies of the same process in the main memory. Step one, I want to create a copy of my process, but I don't want both to do the same thing. But if they're both doing the same thing, that's garbage, correct? I want one of them to do a sub I, one of them to do a sub I plus one, third one to do a sub I plus plus, and so on and so forth. So how I call the fork is important. Okay? I must be incremented before I invoke the fork. Because what will the fork do? Fork will literally fork the process, current process, call parent, and create a copy of this parent, child. Okay, create a copy of this exact copy. Only big difference is the program counter for both processes will be exactly when I call the fork. Okay, it's not a brand new process. I don't want the process to start from the beginning. So remember, how do I execute line by line code? By looking at the program counter. So when you invoke fork, two processes will be in the main memory now. The current process that called the fork and the newly created child. Both processes, the program counter is pointing to fork, right at the end of the fork. So once the copy is created, when I'm done forking the processes, both processes program counter is right here, whatever that line of the code is. So now I need to figure out what is parent going to do and what is the child going to do. I need to control that. It's a copy of the parent. Everything got copied. The variable, okay, the value of the variables that I had it before I forked it, anything happened before fork is copied over. Program counter is pointing to the next line. So I need to know now, am I a child or am I a parent? Number one, because I need to do different things. Because if you're doing the same thing, this is garbage. Okay? Some people want to create the same process and run them at the same time. I don't know what the use of that is, but you can find a use for yourself. Here, I have a specific request. I'm trying to split the process and do less work in each. So first I need to figure out who is the parent, who is the child. Fork always returns a value. Okay, fork, method call, that's a method call, system call, will return a value. To who? To both parent and child. Because when you return from the fork system call, you return to the parent process and the child process. You have two processes that are created. So once you return, you will both have a return value from the fork method call. The return value for the child is 0. I can look at that value and I said, if the value is 0, I am the child. I am the newly created process. I'm going to do this only. If this is parent, the value returned is greater than 0. The value returned is greater than 0. What does that mean? The value returned to the parent is the ID of the newly created child. Okay, that's why it's greater than, I don't know what the value is, so it's greater than 0. So if the value the OS assigned for the new process is 13, 13 will return to the parent. Why? Because the parent needs to know how many children are out there in the OS right now. Am I spawning enough? Have I created enough children in the system? How many did I need? I needed 10. So I can keep a count. Whenever the value is greater than 0, increment the counter. Once I have 10 children, stop creating more children. Okay? Question and question?
Can you repeat that? You're saying, what if you have like multiple children?
I only created one.
Oh, say it again?
I only created one right now.
Mm-hmm.
Let's create multiple children in a second.
Okay.
Okay?
So the value returned to the parent, that wouldn't be the number of children?
Say again?
The value returned to the parent, that wouldn't be the number of children?
It's not the number of children, it's the identifier for the children. Process ID.
Process.
Every process in the system, every program has an identifier. Have you, what OS do you use?
Windows.
Windows. Have you used the task manager?
Yeah.
When you open the task manager, you will see something called PID.
Mm-hmm.
Each process that is currently loaded in the main memory has a process ID. What is it used for? OS uses it to keep track of all the processes. Why? It needs to know who is alive, who is running, how much stuff I have given to this particular process. So when they die, I need to take it back. Here, the parent is keeping track of how many children is creating. It doesn't need to do anything with that value. Okay? The value that is returned to the parent, it doesn't need to do anything with it. But it has that available. Because one thing the parent can do is, just like it created the children, forked the children, it can kill the children. Okay? This has nothing to do with real life, so don't get offended, please. Just a process in Unix that you can invoke. Just like fork, you can invoke a method called kill. Literally, and pass the process ID to it, and say, I want this process to be killed. Why? Because I'm about to leave the system. Anyone that I created to do my job, my sub-child processes, I want them gone. This will stop in the system. It will say, no, that process is still running, still active. But the parent's like, but I want to leave. I want to go. I'm done what I'm supposed to do. If the child is not done, who cares? I can pass a parameter. This is definite kill. Okay? -9 value for kill method is literally, don't stop. Just whatever they're doing, kill them. Whatever resource they have, whatever calculation they have, don't worry about it. But the point being is that the parent can manage the processes that it created. Now the good thing is that I have the child with the value of 0 and the parent with the value greater than 0. There's one more scenario that can happen with the fork call. And that scenario is that the operating system was not able to create the process. Okay? Remember, you're requesting to run the process to fork a process, the OS cannot do it. Okay, why would the OS not be able to create a process? What will be the reason?
Can you repeat the question?
I'm trying to invoke the fork method call, and the purpose of fork is to create a copy of the current process.
Yeah.
but the OS failed to create it. What would be one reason that it cannot create the process?
Maybe of a uni system, uni processing system.
Remember, we established that I can only do this if I have a multi-programming system. So even I don't have a mini programming system, I have a multi-programming system, but fork failed. Why would fork fail? There's only one reason that you guys in this class know about. When you as a user were trying to run a program, you type the name of the program on the command prompt or you double clicked. What happened after that? What did the OS try to do for you?
It makes a syscall to run the specific program you click.
Not yet. It has to go through many steps before it can run. Before I can get to CPU, the OS has to do something for you, for the user program. What did the user do before it could run the program? I just did it a few minutes ago. Say it again? It has to allocate main memory to that program. So if that's the case, based on that, why would fork fail? How much main memory you have in your computer? Eight gig? 16 gig? 32 gig? 16. Have you ever tried to run a program that is very big?
And I run games.
Which are how many gigs? 100 gig, and you're able to run them. How? You only have 32 gig. How are you able to run a 100 gig program?
The OS,
I'm going to go back to my second day of the lecture. You type command.exe, hello.exe, you hit enter, you double click on the program. OS will find the program in the secondary memory, bring that program to main memory. Then it will take the program counter from the instruction memory, allocate that to the PC register. And then the program can execute. Step one, the OS must bring the program to main memory. That has been the fact throughout this semester until we learned about virtual memory. Virtual memory, you can run programs that are bigger than what you have in the main memory. So step one is, do I have main memory available enough to allocate? Only reason fork fails if there is no memory available to allocate to the newly created process. So fork failing, going back to the other question that was asked earlier, do online compilers allow that? They don't, because the system may run out of the memory. And that is the reason, because what is fork doing? Creating more processes. And how do you create more processes? You bring them into main memory. If you don't have main memory, fork will fail. And the result will be return value of -1. Or, depending on implementation, less than 0. It's a negative value. So 3 scenarios, negative value, fork failed. Who cares about that? The parent. Because if the fork failed, something went wrong. I tried to create a process, I was not able to. The value is greater than 0, success, child created. Okay? Third scenario, value is 0. Who's going to get that return value? The child will get that value. Parent doesn't get that value. Yes, and then yes?
So what are the different scenarios that can cause the fork to fail?
Main memory. Loss. That's all you need to know for this.
You said it's
OS. OS creates the process, there are multiple. I cannot assign other resources other than main memory. I need a file. I need an IO device. I need any other resource that will make me ready to execute. I don't have that, I cannot be created.
Let's say when you run the program and it meets the fork and then it fails, does it just kill the program or it just makes
It didn't. Remember, what's a fork?
It just splits the.
No, what's a fork? When you write fork in your code, what are you trying to do? You're making a function call. The function call belongs to the OS. The program is still executing, correct? So if it fails, it will return to the parent. And the parent will grab that value. So if less than 0, oops, literally. Because what I'm trying to do is multi-programming. I'm trying to program and split that into 10 programs. Okay? So let's see, it doesn't fail. Everything is good in the world. Now I have child with value 0. So within that code, right after the fork, they both are pointing to the same point. The program counter is pointing to the same code. So I need to, remember how I created the child? I call the fork and it copies the code all over. It's literally a copy of the parent. So you as a programmer need to write the code so it does different things depending on who is running. So right after the fork call, you need to have if fork equals 0. What does that mean? Fork is returning the value 0. Who will it return the value 0 to? To the child. So when I'm here in the if statement, this part of the code will be evaluated by the parent also. Parent will compare the value, return value, but the return value for parent is greater than 0. It will not do anything with it. It will fall to the else part. So that if else part, one will be executed by the parent, one will be executed by the child. So you as a programmer have to change the code. We'll finish this up on Monday. Yes?
So, oh, okay, because the child returns 0.
The value returned to the child.
Yeah.
I have 2 processes in the system now. They both get a return value from the fork method call. I don't know who is who yet.
Oh, it's not it's not, the 0 isn't being returned at the end, it's being,
After the fork is done. So what is the purpose of fork? Create a copy. Create a copy, both are ready. Where is the program counter? Right after the fork call. So once the child starts running, it will say, okay, what was the return value? 0, I am the child. Parent, what is the return value? I am the parent. And they will run different codes, hopefully. Yes?
So you're saying that you're not gonna specifically handle a case for the parent because it could be different each time?
What do you mean?
Because you're only catching it with an else state.
If the value is not 0, what is the value?
Greater than